Alright, let's look at the homework 6.5, problem number 7. Alright, so it's a cold drink is taken from the refrigerator and the temperature is 5 degrees Celsius. And after 25 minutes later, in a 20 degrees Celsius room, its temperature has increased to 10 degrees Celsius. Right? So this is actually not cooling, it's actually warming up. Right? But we can apply the same formula. Right? So let's do this one. All right, so let's see. Initial temperature is 5, so I'm gonna just write that down. So T0 is 5. All right, and let's see. Temperature of the surrounding T sub s, TS, would be 20. All right, and it's increased to so let's see. Temperature has increased after 25 minutes. So maybe I'll say T of 25 is equal to 10, right? So that's the given information, right? So remember that Newton's law of cooling, and T of T is equal to temperature of the surrounding plus initial temperature minus temperature of the surrounding times e to the kt. Right? So let's plug these numbers in. So temperature of the surrounding is 20, right? Plus, right? Actually, this is the initial temperature. Initial temperature is 5 minus temperature surrounding is 20. Then you have e to the kt, and which simplifies to 20 minus 15 e to the kt. All right, so we have that. All right, then we can use the last condition to find maybe e to the k. All right, so I'm going to go here. T sub 25, T of 25 is equal to 20 minus 15 e to the k times 25. So this is supposed to be equal to 10. All right, then subtract 20. So we get, let's see, maybe go here. Subtract 20. We get the negative 15 e to the k times 25 is equal to negative 10. Right? Then divide through by negative 15. We get e to the k times 25 is equal to, let negative sign cancel out, 10 over 15, which is 2/3. Right? So we can just raise both sides to 1 over 25 power. We get e to the k is equal to 2/3, raise it to the 1 over 25 power. All right, so we have the formula. So formula is going to be T of little t is equal to 20 minus 15. E to the k is 2/3, and the t to t over 25 power. All right, so all we need to do is this is after 50 minutes, so we just have to plug in 50 for t. So let's find the t of 50. So this is going to be equal to 20 minus 15, right? Then you have 2/3, raise it to the 50 over 25, so that's actually 2, right? So I'm going to just go ahead and put 2 there, right? So let's compute this value. All right, so we brought out a calculator, and so we're going to compute 20 minus 15 times 2/3, 2 divided by 3, and raise it to the it's just square, right? So let's compute that. All right, so we got 13.33. So we have 13.33 degrees Celsius. Right? So let's do part B. When will its temperature be 13? So we just have to set this temperature function. So T of T, which is 20 minus 15, 2/3, raise it to the T over 25. We're going to set that equal to 13, right? So subtract 20 from both sides. We have negative 15 times 2/3, raise it to the T over 25 is equal to negative 7, right? Then we can divide that through by negative 15. So negative sign cancel out. So you have 2/3, raise it to the T over 25, and is equal to 7 over 15. Right? Then we're going to go ahead and take the natural log of both sides. Right? This will give us, using the log property, I'm going to put the T over 25 in front. Then you have a natural log of 2/3 there. And this is equal to a natural log of 7 over 15. All right, so in order to isolate T, we need to multiply by 25 to get rid of that, and divide by natural log of 2/3, right? So what you get is going to be 25 times natural log of 7 over 15 all over natural log of 2/3, right? So let's compute this value, right? So it's a 25, right, multiplied by natural log of 7 over 15, right? Then divided by a natural log of 2/3, 2 divided by 3, right? So let's put that. All right, so it's 46.99. So it's going to be 46.99 minutes. All right, so let's type this guy in. All right, so what we found for part A was 13.33. And for part B was 46.99, right? So let's go down and submit for testing. All right, it came back and looks like we got both of these guys correctly, right? Right, that's it. I hope that this was clear.